find the tip of a line shown on each graph. So this is one, they pick the points for you, but you can pick any 2 points on this line, Keyshawn, and then you're going to use rise over run. So this is when we use, we should have used rise over run, where rise tells us how far we go up or down to get even with the next point, and then the run tells us how far we go left or right to actually get to that point. So if we started at this point, how far do we have to go down to get even with this point? 1, 2, 3. So down on the coordinate plane is -3, remember? Negative, positive, right, positive, left, negative. So now we're even with the point. Do I need to go left or right? Right. 1, 2, 3. So we're going to go right 3, that's a positive 3, right? So -3 divided by positive 3, just do it on a calculator, that's how you get the slope of -1. Yes. Simplify or divide, whichever way you want to think about it, but yes. Anybody else have a question on Friday's assignment? All right. So we can get this thing off on my screen. Yes. So there's a lot of problems on this paper. I'm going to do at least 11 of the problems with you. So you'll only have 23 problems. At least 3 of the problems are super simple. All you have to do is use your notes. I'm trying to keep track of the ones I did with first period, so we can kind of do the same. And we're going to use these to do our notes with. This is a part 2, 5-1, part 2. The name of this section is rate of change and slope. Let's just go ahead and start with some definitions. So the name of this section is rate of change. Really all rate of change is a slope when you're talking about a real world problem. So the rate of change is just a slope when it applies to a real world problem. Exactly the same, we use the same formulas of y minus y divided by x minus x. I'm going to abbreviate, I'm going to abbreviate that R series, O series, C series from here on out. So rate of change is this one is applied. What's that? You can't do it the first 2 minutes if I'm telling you. It's not even my rule. Right? So we don't go during the note. Is it an emergency? Is it an emergency? Go ahead and go leave. Make sure you sign out. 9:37. We'll be back as soon as you can. All right. So the first of the directions says determine whether each rate of change is constant. If it is, and it means if it is constant, find the rate of change and explain what it represents. So here, constant rate of change is going to mean that the relationship is linear. Constant rate of change means the relationship is linear. And we can determine if it's a constant rate of change if y divided by x for all values equals the same number. to determine, is it a constant rate of change? If it is a constant rate of change, we're going to state that, and we're going to tell what it means in this real-world context. Danielle, I think you're good now. Danielle, do that. Okay, so let's look at number 1. It says, here are the notes, find the directions, determine whether it's a constant rate of change, and if it is, find the rate of change, and tell what it represents. So, when you see this table, you'll see here that it refers to the hockey team's offense, where this is the input, this is the output. After one game, they have 2 goals. After 2 games, they have 4 goals, or in the first 2 games, or in 2 games, they have 4 goals. In 3 games, they have 6 goals. We should recognize the 3 input-outputs represent ordered pairs. So this ordered pair would be 1, 2. After 1 game, they score 2 goals. You should be writing what I'm writing on your paper. 2 and 4. Pretty nice. 3 and 6, right? X, Y coordinates. Those are the X coordinates. These are the Y coordinates. So, if we want to determine if there is a constant rate of change here, we're going to take all the Y values and divide them by the X value that will be part of their ordered pair. If they're all the same number, we say yes, it's a linear relationship with a constant rate of change, and then we're going to tell what it means. So we're going to start with this first ordered pair. 2 divided by 1 equals 2. Then we're going to look at the second ordered pair. 4 divided by 2 equals 2. We're going to look at the third ordered pair. 6 divided by 3 equals 2. All of them, when you take their y and divide by their x, you have a constant rate of change. You have the same number. That number is constant. So I don't have room to write what that means here. So looking at this, what do you think that 2 means? If you look at that table, how would you say, what does that 2 represent? Anybody have an idea? So the average goal they make is 2, right? So for every game, they score 2 goals, right? So their total goals, and they actually don't really tell us, but it could mean that every game they score 2 goals, or it could mean that each game they increase their goals by 2, right? I think that's what it means. So the goals increase by 2 each game. That's how we should work, and we're going to describe it as the rate of change of 2 means for every game played, their goals increase by 2. Let's say there, if that's the total will increase by 2. Any questions on that? So the next section we did yesterday. We'll go back and do one of these examples, probably last time we did in first period. This next one we also did In fact, you're just going to use your notes from Friday. You shouldn't even have to do any work. Use your notes from Friday. It should take you 1 second each. I'm not going to count those problems in your total. Technically, you're going to have 23 problems, but these literally should take you 1 second. No work required. Just look at your notes from Friday. Okay. So the next group of problems, without graphing, we're going to tell whether the slope of a line now model each situation is positive, negative, 0, or undefined. All right. So remember we have 4 types of slopes. Those are the types of slopes, right? On a graph, we know what they look like. Up from left to right is positive, down from left to right is negative, a flat horizontal line is 0 slope, and a vertical line is undefined slope. But what does that mean if we're not looking at a graph? So our types of slopes, and you're going to put these in your notes. So a positive slope. If you don't have a graph, you need to know if both inputs go up, or if both x and y goes up, or both x and y goes down, that's a positive slope. So an increase and an increase is a positive slope. But a decrease and a decrease is also a positive slope. Think about the fact that a negative times a negative is a positive, right? Positive times a positive is positive, and a negative times a negative is also positive. A negative slope means that if my input decreases, my output increases. Or if my input increases and my output decreases, think about it, negative times a positive is a negative number, right? And the other thing would be, well, if my inputs increase, but my outputs decrease, that would be a negative number. And by input and output, we're really talking about x and y. Right? If my x value increases and my y value increases, that's a positive slope. So we're talking about increase in x, increase in y. A 0 slope. Y is always the same. And undefined slope, x is always the same. This is your first time notes to graph. Most of this stuff I'm not used to going over your notes. If you're taking it all on your notes, on your worksheet, make sure you post your worksheet and notes thing, I guess. Always say. That's all right. Like I said, if you're taking all of your notes on your worksheet today, just upload your worksheet to bonus class. Okay, and I'll read it from there. Are y'all fine with me? All right, so let's look at number 16. So the cost of tickets to the amusement park is $19.50 for 1 ticket and $78 for 4 tickets. All right. So we're talking about a number of tickets and the cost for being in the amusement park, right? So we should recognize this number goes with this number. This number goes with this number. Those can be written as an ordered pair. We're going to talk about definitions here in a second, but we need to know what is it independent variable and one is a dependent variable. We're going to talk about it now and we'll write it down in a minute. So which one of these depends? So does the number of tickets depend on the cost, or does the cost depend on how many tickets you buy? What would you say? The cost depends on the number of tickets you buy. So the number of tickets is your independent variable, and the cost is your dependent variable. So your independent variable is going to go in your X spot, and your dependent variable is going to go in your Y spot. One ticket costs $19.50. 4 tickets cost $78. XY, right? So are both of these increasing? Do the X's and the Y's both increase? So another way to do it, you could actually plug these into the slope formula if you're not sure about it. This one in particular, you could use the slope formula, but we don't really need to do that because we know they're both from 1 to 4 goes up, from 1950 to 78 goes up, so we know it's going to be a positive slope. So now we're going to find the slope. And so we're going to do M equals Y minus Y, remember? M equals, so this is the rate of change. It says slope is also the rate of change, Y minus Y over X minus X. So this is also the rate of change. Because it's a real world problem, usually they call it rate of change. I don't know why they don't do that here, but I guess because they're talking about when it's graph. So Y minus Y, 1950 minus 78 divided by 1 minus 4. If you do that on your calculator, what'd you get? 1950? So if we're putting on the calculator to do 19.5 minus 78 equals, divide by parentheses 1 minus 4 close parentheses equals, yeah, you should get a positive 19.5. So slope is not going to have a dollar value. We're not talking about dollar value now, even though that's the same as the price of one ticket. What this means is that every ticket costs $19.50. So it's going to increase by $19.50 each time. All right, so I'm not going to do the other three. We're going to let you guys try to do those on your, oh, actually I lied. We're going to do number 17. We'll do number 17 for experience. All right, so number 17, it says the late fee is $2, regardless the number of days the movie is late. So, it just independent dependent variable doesn't really work here, but usually a late fee will be based on the number of days late, right? So if this movie is 1 day late, how much is the late fee? $2. If this movie is 10 days late, what's the late fee? Sorry? $2, right? So what this says is no matter what, the output or the Y is $2. So which did we say that was? Is that 0? Yes, 0. It stays the same. So that is a 0 slope. Alright, so now we're going to talk about independent and dependent variables. So we talked about it a little bit before, so let's put in our notes. Typically the independent variable is your X value. That's your X value or the input. So if does not depend on the output. So like in our other example where we had, if you buy one ticket, the cost is $19.50. The number of tickets is an independent variable because the cost depends on how many tickets you buy. Now, it doesn't have to be an X if there's another letter there, but it's that first number in the ordered pair, right? And a dependent variable depends on the X value, depends on the input. And we call that the Y or the output. Are y'all tight with me? So let's look at an example of that. So let's look at 20. We state the independent variable and the dependent variable in each situation and find the rate of change for each situation. Remember that the rate of change is just another word for slope. And that's y minus y over x minus x. So once we know what the independent and the dependent variable are, we'll know what numbers to plug in to our slope formula, right? Because we'll know which values are x values and which values are the y values. So looking here, Shelley delivered 12 newspapers after 20 minutes and 36 papers after 60 minutes. So what do you think is the independent variable and what do you think is the dependent variable? Well, I'm going to give you a hint. Time is almost always the independent variable. Yes. So here, time is the independent variable, and the number of papers is the dependent variable. Does that make sense? Because you can deliver more papers in more time, right? So in 20 minutes, they delivered 12 newspapers, and in 36 minutes, they delivered in 60 minutes, they delivered 30 papers. So we could write our ordered pair. What would be the ordered pair for the first two numbers? 1220 or 2012? 2012, that's right. And here, the other one would be 6036. So now we know that this is an X, this is a Y. This is an X, this is a Y. So now we can plug in for our formula. M equals Y minus Y. So 12 minus 36 divided by 20 minus 60. The order doesn't matter. Did I do it wrong? 12 and 20 and 36 and 60. No, I did it right. Right. Y minus Y divided by X minus X. Does that make sense? No, Kira? Is that confusing? No. Okay. So on our calculator, you may just want to go ahead and do the top, the bottom, and then divide. It's going to be negative 24 divided by negative 40. What do you get? So you can also do ABC. It'll simplify your fraction for you. We really want a fraction for our slope, not a decimal. What do you get? don't think so. Yes, it should be 3/5. So try it again. You should get 3/5 to the slope. And that is a really common mistake. You gotta be careful. Putting things backwards, not putting the same input, not putting the input first for both things. Lots of places to make mistakes on these. You gotta be careful. All right, questions on 20? All right, so let's go down and do some of the word problems that you guys don't like to do by yourself. Let's do 29. Explain why the slope of a horizontal line is always 0. So I have an example here where I have a horizontal line and I've plotted 3 points on it. Can someone give me the ordered pair for this point? Can you give me that ordered pair? This is the origin. What is the ordered pair for that point? Tushan, can you tell me? Yes, -2, 3. And how about the ordered pair for this point, Nicholas? Can you tell me? What's here? Okay. Can you tell me, Braxton, what is the ordered pair for this point? So, you have to be able to plot points, guys. If you're having trouble with writing ordered pairs for points or being able to plot them, that's something you need to practice. Because we're about to get really into that a lot more. Ryan? Yes. So you start at the origin, you decide whether you have to go left or right. Here we have to go right, and we have to go right once, that's a +1, right? And now once we get here, we decide whether we have to go up or down. We have to go up, so we go up 1, 2, 3. So that's the ordered pair there. What is the ordered pair for this one? Brooklyn, can you tell me now that I've explained it? Start here. How far do we go right? 3, and how far do we go up? Yep, that ordered pair is 3, 3. What do you notice about those ordered pairs? They all have 3 for their output, or 3 for their y values, right? So if we're putting an explanation here for why is the horizontal line always 0, because no matter what x is, y is always the same value. That's what you're putting for number 19. We just did number 19. So much for you to do. Number 30, describe how to draw a line that passes through the origin and has a slope of -2/3. So this is number, I said 19, it's actually 29, might be 29. It's right there, so if you're getting all flustered, sorry, but literally it's on your paper. This is number 30. It says, describe how to draw a line that passes through the origin and has a slope of -2/3. So go ahead and draw that origin, or that coordinate plane, and just mark 3 on each side. Alright, so let's do 4 up, 4 right, 4 down, and 4 left. Little tick marks. Remember, this is the x-coordinate, this is the x-axis, y-axis. If you go right, it's positive. If you go left, it's negative. If you go up, it's positive. If you go down, it's negative. For the origin is where these x and y axes meet. So let's go ahead and plot that point. We're going to plot that point because it says our line needs to go through that point. Right? So if you want to draw a line, you only need 2 points. Typically, when we're graphing lines, I'll ask you to give me 3 or more, but you technically only have to have 2. I can draw a line through any 2 points. So I have 1 point at the origin. if the slope is negative 2/3, how could I, how could I draw a line? So with the slope of negative, so this one says negative 2/3. Let's move the negative up into the numerator. And so we're going to write the slope as negative 2 divided by positive 3. We can put that negative in the middle, we can put it in the top, or we can put it in the bottom. It doesn't really matter what that negative sign goes, it means the same thing. So anybody have an idea, how can we plot a point, and then so we could draw a line through it? Anybody have an idea? Horace, do you have an idea? Diane? Negative 2 for the x and positive 3 for the y. Well, I think your point's going to actually work out right, Diane, but it might not always. Let's think about this as the slope is rise over run. Okay? This tells how far to go up or down. This tells how far to go left or right from any other point, right? So if this is our point, if we go down to, so yours would work, but it's not working with my example, right? So if we put the negative in the bottom, yours would probably work. Negative 2 up 3, yours wouldn't work. All right? So, but since we put the negative in the top, we're actually going to go down 2 and to the right 3 if we're using our rise over run format. Does that make sense? Danielle, you listening? What I just said? You don't know? Okay, so one more time. In this instance, we're using this to slope of the rise over run. So if I have one point, I can count using my slope to get another point. So here I can go down 2 and then to the right 3. 1, 2, 3. Down 2 to the right 3. And then I can draw a line through my point. So I use the rise over run to find my second point. The origin is my first point. So we're going to have to describe, 1, plot a point on the origin. 2, use the slope in rise over run form to plot the second point. And 3, draw a line through the 2 points. Does that make sense? Use the slope and rise over run to plot the second point. And then I just did some other problems with the kids in first period, so you'll have fewer problems to do from your homework, and you'll have some examples. So we're going to do number 32. So each pair of points lies in a line with a given slope, find x or y. So this is one where you're not finding the slope, but you're still using this formula rather. So I'm going to do it down here so I have more room. So I'm going to plug the slope. I already know the slope goes in the end spot. Right? So remember, this is x, this is y. This is x, this is y. So y minus y is going to be y minus 4 in the numerator and 5 minus 6 in the denominator. So we do need to go ahead and simplify this. When you're calculating, 5 minus 6 is negative 1. Now we need to be able to solve this equation. So what are we going to do to get the y by itself? Remember, if you have more than two things in a fraction, you need to put the parentheses around them. This is the exception to the rule. We're not going to undo the subtraction first. We're going to undo the dividing first. So what are we going to multiply by to undo the dividing? What are we dividing by here? Negative 1. So we need to multiply by negative 1 to undo it. So negative 1 times 0 is 0. And these are going to simplify. So now we have y minus 4 equals 0. Undo subtracting by adding. And now we know that y equals 4. Okay. You guys cover me? Alright, so let's go up here. We did, let's do number 32. 32, we're just using the slope formula. Oh, I'm sorry, what is that one? 22. Let's do 22. Y minus y equals, is it 23? Might be, I can't read across through it. 23, this one right here. Y minus y over x minus x. This problem is weird. This number goes with number 25. Do you guys see that? That's the other part of 25. That's the y coordinate for 25. They have a weird printing format there. So for 22, we're just using the slope formula. We are finding the slope. We don't know what the slope is, but we know the x and y coordinates. So we're going to plug in. What's going to go in my numerator? What's going to go in my numerator, do you think, Jacoy? What's going to go in the numerator, the top?
0 minus 5.
Perfect. And then what's going to go in the denominator, Martin? Yes? Always minus, right? Minus what? Negative 5, right? We're doing the x's now. We did the y's on top, we did the x's on the bottom, so let's put our parentheses there so we don't forget our negative. Now we're going to simplify the top, simplify the bottom. What is our slope going to be? What is our slope? Heard somebody say it. Put it on your calculator. Not negative 5. Put it on your calculator and see what you get. What's negative 5 divided by 0? If it's not 0, do it on your calculator. What do you get? It's an error, right? What did we say it is when it says error? Thank you, Swan. Undefined. So you can have a 0 on the top and any number on the bottom, but you can't have a 0 on the bottom. It's undefined then. All right, so let me see what other problems we did together. Let's do one of these. Find the slope of each line. So remember, this is a rise over run. We're going to use a rise over run for these, and this is where you just count from one point to the other. So I'm going to give myself 2 points from here to here. If they give us a line on the graph, technically we could write the ordered pairs. I'll go back in a second so you know what you mean. When we're done, well, I don't know, we're probably not going to have time, but it's already less than 10 minutes down, so you can't go, it's already less than 10 minutes, my bad, or, I'm sorry, not really my bad, but I'm sorry. Alright, so what we're going to do is we're going to count from one point to the other. It doesn't matter which. I'm going to start at the bottom, and I have to go up how many to get even with that point. So put your points in the same place I put my points. They go up 1, 2, 3, 4. That's right. So up 4, is that positive or negative 4? Positive 4. Now once I get up 4, do I have to go left or right to get to my line? Is that positive or negative? Positive. And how far do I have to go? Very good. Positive 2. So if I do that math, then my slope is 2. And I would get the same answer if I started here. I would go down 4, negative 4, left 4, negative 2. Negative divided by negative is a positive. 13, 14, and 15 should take you half a second apiece. Use your notes from Friday. Use your notes from Friday here. did one of these, 7 through 12. Anybody have a preference which one you want me to do? I think I did 7 or 10. We do one of those together? Whatever we do now is less for you to do at home, right? 7 it is. Okay, so here we're using y minus y over x minus x. So y and y, x and x. So make sure when you plug into this formula that these two numbers, you have them stacked. The order pair should be stacked on top of one another. 1 and 2 go together, right? Y is the 1, x is the 2, the same order pair. And 0 and 0 go together. That's going to be 1 over 2. So your slope is 1/2. I've done as many problems as I did with them in first period. Oh, yeah, let me see. Oh, you know what? I think I did this fraction one. So let's do number 26 together. One less fraction one we have to do, and I'm going to write it down here. So this one, we're just finding the slope, and it's got fractions. So I'm going to remind you how to do that on your calculator. So we're going to plug in y minus y, so these are the y's. So 3/4 minus 3, negative 3/4. That's y minus y. And then x minus x, negative 1/4 minus positive 1/2. So if you can't read my handwriting, once again, that's 3/4 minus negative 3/4 over negative 1/4 minus 1/2. Remember, these are the y's, these are the x's. So on your calculator, use your ABC buttons, and you don't, these fractions are no different than any other buttons, because we give you, any of the numbers, we get to use our fractions. So it's 3ABC minus negative, minus left parentheses, 3 positive negative ABC, close your parentheses, or 4, close your parentheses. You get 0? So try it, you should get 0. Oh no, I lied, you should not get 0. What should you get? You should get 6/4, right? 6/4. Try it again. Or I'll do it. So 3 ABC 4 minus left parentheses negative 3 negative ABC 4 close that and equal. So now that's a mixed number. We want it as a fraction. The second ABC. It is 6/4, so that simplifies to 3/2. Your calculator will do that for you. Now do negative 1/4 minus 1/2. So 1 positive negative button ABC 4 minus 1 ABC 2, and then equal. If you don't practice using your calculator, this button doesn't help you. Okay, Karen? I'm just letting the calculator do it for those kids that they don't remember that. So you're right. You could just turn it into a plastic Kara. But, say it again. 1/4 minus 1/2 is not negative 1. What'd you get? Yeah, I believe it's negative 3/4. Now for this, you can't do 3 ABC 2 and then enter ABC for the fraction bar. You can do 3 ABC 2 divided by 3 positive negative button ABC 4, and then equals, and then turn it back into a fraction using that second function. So you should get, say it again. I can't remember if it's negative or positive. You may be right. what you're supposed to do. Right? The three of us are really, you all really have 20 problems to work. And I'm giving you an example on all of them. Sometimes more than one example. How did it go?